Right, people, I'm back. Sorry, I had a bit of a brain cramp there and the video paused. But all right, we're back with this absolute value graph of integral from 0 to 2 of x minus 1. So here's the graph of that function. And if you remember from math 12, I believe. So this, I'm going to do this in different colors here. This part of the graph is the graph of x minus 1 because there's the graph of x minus 1. It's just a line. We absolute value it, this part flips up. So this part of the graph here, 2 in orange, this part is negative x minus 1. That's how you get it to flip up. So there's two parts of this integral, and it's divided by 1 here. So this is actually, to get the area from 0 to 2, 2 is out there. So I want this area, and I want this area. So you have to go integral from 0 to 1 of negative x minus 1 dx plus the integral from 0 from 1 to 2 of x minus 1 dx. So it has to be broken into two different integrals. And depending on what the graph looked like, it could be 3, 4, whatever. It could be an infinite number. Then you evaluate each one separately. So I'm just going to rewrite this as negative x plus 1 dx. Okay. So this is going to be negative squared over 2 plus x evaluated from 0 to 1 plus, this is going to be x squared over 2 minus x evaluated from 1 to 2. Put in the 1 first, so I get negative 1 squared over 2 plus 1 minus, the 0 is nice because everything goes away, so I'll write it in anyway. So there's the first bit, plus then the second bit, 2 goes in, minus, just watch your negatives here, people. 1 squared over 2 minus 1. Alright, so start simplifying. This is negative 1/2 plus 1. This is all 0. I get u squared is 4, that is 2, minus 2, minus 1/2 plus 1. 2's go away, negative 1/2 minus 1/2 is negative 1. 1 plus 1 is 2. The answer is 1. All right. So when you have an absolute value, think about the graph and think about how you're going to have to break it up into two separate components. All right. Last question. Number here. 4, 5. Number 5. Find the area bounded by, well, let's just do y is equal to 3x squared minus 2x plus 1. That graph, the x-axis, x is equal to 0, and x is equal to 2. Okay, so Oops. Okay. So let's sketch this graph quickly. So this is going to be a parabola. So this graph looks like this. Has a y-intercept of 1. Down, and it looks like that. Bounded by x is equal to 0 and x is equal to 2. Just guess where 2 is. So we're finding this area in here. Okay. So what that means is setting up the integral from 0 to 2 of this function with your variable integration dx in it. Okay. Integrate it. So any number of these can all be done separately. So this is the same as, now you would never write this, but I'll just do it now. You would never write it like this unless you were doing a proof of some sort, usually. In practicality, you would just write it all out in one step. 1 dx, dx there. And so you would just go 3x squared, add 1, divide by 3. So really that's just x cubed, evaluated from 0 to 2, minus x squared, evaluated from 0 to 2, plus x evaluated from 0 to 2. Now that's kind of a convoluted way. Still right. Is just go, oh, okay, that's just going to be x cubed minus x squared plus x, all evaluated from 0 to 2. All right, so then put in 2 cubed minus 2 squared plus 2 minus, so it's nice to know zeros because they all go away. So it's just 2 cubed, which is 8, minus 4 plus 2, which is 6. And there you go. So I find it helps to draw pictures sometimes. You don't have to, but if you need to have a visual, that's nice. And you know this area is 8, or sorry, 6. Wow. Sorry. 6. There you go. All right. Questions from the book. Page 288. Numbers 23 and 25 now, but you can do them because those are the absolute value questions. 35, 39, 41, and 66, but number 66 don't do F, the average value function, but don't worry about that. Okay, email me if you have any questions. Thank you.